I have a point on a graph. I know that's a critical point. I know it's a relative max or a relative min. So I did my first derivative, set it equals 0, and I got an x value. I would check if it was a relative max or min by plugging into the derivative. And then I can say, well, if we were increasing prior and decreasing after, that must be a relative max. Agree with that? If we were decreasing prior, increasing after, it must be a relative min. Well, there's another way you can check that I don't really think many people use, but you can. So if the second derivative is positive, then the point has to be, see if you can think through that, relative max or relative min if the second derivative is positive. Mr. Heiko. Good. So the second derivative being greater than being positive means the original graph is concave up. Concave up looks like a U. If that's a U, doesn't that have to be relative min? And then the opposite would be true also. So if you have a point and the second derivative is negative, now it must have been concave down, so now that must be a relative max. So 5-7 has you practice that. In my opinion, you did above and beyond that when you did your take-home quiz. And we don't need to cover this. 5-8, we're going to get deep into. I'm going to draw probably like, how many graphs do you think? 4 to 6. We'll start with 4. So I'm going to draw a graph, and then on top of that graph, we're going to draw like a graph and its derivative on the same graph. Cool for me up here because I have the markers. I can do like the original in blue and the derivative in red. But if you have like a pen and a pencil, or you have colored pencils, let's go through 4 of them. One color. I mean, you don't need 2 colors. You can do like a solid line and a dashed line. First, I thought you said they were racist.
They are. Yeah. Typical.
These pencils are typical colored pencils. So let's say I don't even care what the x values are or the y values are. I'm giving you an original graph. Our job is to graph the derivative. Well, there's a blank sheet after 5-8 in your notebook thingy. Grab that, and we're going to do 4 different graphs. So space those out. Can we wait for you, or is this awkward? Can we wait for you? No, it's all right.
No, we should wait.
We should wait.
No,
I
we
feel like we
can
should
wait.
wait.
Yeah, we can wait.
In Will's position, he probably feels like a lot of pressure.
No, we can.
Go, Will. Hurry up. Come on.
How are you? Yeah, let's go watch it.
Damn it, Will! What's taking so long?
I'm waiting.
Whoa.
Oh, can I tell you guys how I almost died today?
Yeah.
Well, we're waiting for Will.
Wait, do you
Yeah.
want Gavin to explain it while you're explaining it?
He was trying to explain the car accident he was in, and Gavin was trying to predict it.
Alright, so on Celine Island Road. Hold on. Well, I'm trying to buy some time.
This is the opposite way. We're getting a different perspective.
Oh, yeah. No, you're right. I'm coming down Celine Island Road,
Yeah, there you
going around this turn. This. Oh.
go. It's okay, we're buying a little time.
You can use your dotted line thing.
No, it was a
Oh,
solid.
because it's freaking solid line.
Just pass.
That's the point. So in the middle, this is my yellow line. There's double yellow lines. This is me. Going this way, approximately 55 miles per hour.
Changes every time.
Well, because did I say?
He wanted to see if he was going fast, but he wasn't going over the speed.
Yeah. This is a garbage truck
Driving responsibly.
going probably like 20 miles an hour. Which is fine. It's a garbage truck. So I come around this corner. This is like trees and you can't see anything. There's a car here passing the garbage truck going 60 plus. I had to literally slam on my brakes. Like, I'm on Celine Mile, I'm going 55. In like 2 seconds, I'm going 0. I'm stopped. And as this happens, the garbage truck is here. The car, I mean, it was like 6 inches from me. Going 60 miles an hour, ducking in before. And if I hadn't stopped, like literally stopped. Good thing Elon makes good brakes. So, glad we survived. Will, are you good now? What's my story still really?
We're grateful you're here.
Okay. My job is to graph the derivative. So I want a graph that represents the slopes of this graph. So the first thing I always start off with, if it's there, sometimes it's not, but I know the slope right there, I know the slope right there. Like I know exactly what there. Anywhere else I'm estimating. Like here it's positive, but I don't know what the number is. What's the slope right there? What's the slope right there? 0. So those points go on your x-axis. The next thing I look at is whether, so it kind of splits my graph into parts. You can almost think of it like a number line. In this part is the original graph increasing or decreasing. The graph I can see, is it increasing or decreasing? It's increasing, right? So I'm just going to write that. It's increasing there, we're decreasing there, then we're increasing there. Does that make sense? Is that funny? Like what? Hey, you might want to see a doctor. Okay. If the original graph is increasing, what's true about the derivative? In a minute. Someone said that thing. Positive. So another way to say it here would be f prime of x is positive, f prime of x is negative, f prime of x is positive. So my derivative graph needs to be above the axis for this section because the derivative is positive. Below the axis for this section, and then above the axis for this section. With me? So I need to be up, down, up. This is a weird principle, and I don't understand how people know what I mean when I say this, but let's see if it works. How many wiggles are in that graph? Everyone says 2. What's a wiggle? I don't know. Everyone says 2 though. Do we agree to stop it? Do we agree that it's 2 wiggles? Okay. So, wait, do you actually think it's 1 or are you just being...
No, I don't.
No, it's okay if you do.
Well, I like kind of see it as like 1.
So, like, that's a wiggle, that's a wiggle. Like a turnaround. How about that?
Yeah.
How many turnarounds?
I can see how it's 2.
Alright.
I can also see 1. Because like, is a wiggle like this part, or is it like? You could use the word bend, maybe. 2 bends.
How many bends? How many bends are there? 2?
You guys are singing through signs.
I was gonna say which.
Matthew, stop being typical. He's just being stupid. That's stupid.
So here's what, but it actually doesn't matter because all we want is 1 less wiggle. So if you think there's 2, make 1. If you think there's 1, make 0. If you think there's 3, make 2. But so y equals x to the third looks like that, right? Y equals x squared, which would be like, I mean, there'd be a 3 there, but wouldn't the derivative of anything to the third power be something to the second power? Do you see how this has 1 less wiggle? Whatever your wiggle or one less bend. With me?
Yes.
Y equals x to the fourth would be like that. So it's got an extra wiggle. Y equals x looks like that. So if you had like
That one I get.
some point it's
I
not
got
being-
that one.
some point it's not being funny. So like if you think this is one wiggle, this has like less wiggles, right? It's straight. And then if I go even further, like let's say it was y equals some number, I would say that this is less wiggly than this. We're getting a little bit goofy there, but when you take the derivative of a polynomial, this doesn't work for sine or cosine, because sine and cosine just have like infinite wiggles. When you take the derivative of a polynomial, you lose a wiggle. You lose a bend, whatever you want to call it. So if I lose a bend from this shape, what shape am I going to end up with? A parabola, right? Which the general idea is this is x to the third, so the derivative of that has to be x squared. So we need something that is above the axis here, below the axis here, above the axis here, and looks like a parabola. Above the axis, below the axis, above the axis, looks like a parabola. That's the derivative. I do want to point out one other thing in there. I didn't draw it perfectly, but the minimum here, the minimum on this graph, what does that look like it correlates to on the blue graph? But I could do the same shape like up higher. So I could go like that. I think someone just said it. So it's something like that. It'd be the same idea. It switches concavity. That point of inflection is going to correspond with the minimum there. So that's just one example. Questions on that one? Let's do a couple. Your assignment today is like, I think it's 18 questions with a graph. 18 graphs, 18 derivatives, and you're math. So there's no like help. This is like my favorite thing.
Are you gonna test the stats?
How many of you guys have a cat? I think it's perfect. I think that's like that's the question we came up with at the time. It's like safe, neutral. It should be around 50. Doesn't depend on what grade you're in. It's perfect. Okay. Try that.
So you're not in science like that.
What?
He thinks you're gonna split his throat. I'm also like kind of I would sacrifice.
So that would be more balanced.
Alright, quiet please. So there's our original. So however many bends or wiggles you think that has, we want one less in our derivative. Always going to start off with where, because I'm trying to graph the slope, where does the slope equal exactly zero? That's here, here, and here. And then I'm going to kind of work in those sections. So it splits the graph into 1, 2, 3, 4 parts. In this first part, the original graph is increasing, which means f prime is positive, which means above the axis. Here, and you probably like not write these every time, but it's definitely helpful if you get stuck, or especially as you're learning. So the original graph is increasing, derivative is positive. Original graph is decreasing, derivative is negative. Now I go back to the original graph is increasing, so the derivative is positive. And then the original graph is decreasing, so f prime is negative. So if the derivative is positive, I need to be above the axis. If the derivative is negative, I need to be below. And then I've also, if you want to get very technical about it, the point of inflection is like right here. There's another one like right here. So those should be like our peaks and valleys. above the axis prior to this, and I know that like one less wiggle, starting above the axis, one less wiggle is going to look like that, right? One less bend, one less. Does that make sense? Do you agree with that?
Yes.
How many wiggles does that have to you? Okay, no, you can say 2. Well, then how many is that? Okay, fair enough then. Okay. So I need to have that general shape. I'm going to start up here. I want to bottom out at this x value. Come back up. I want the max to be at that x value. Come back down. And here's the other thing about this, like, that is the correct derivative. So is this. You don't know how big or small they are. So is this. No, never mind. Yeah, I'll do this one. So is this. I can't say anything about the size of the curves. But if you look at any one section, like if you just focus over here, don't those all have the same shape? Going down and going down faster? That's all I can judge. That's all you can do. But any one of those, green, black, or red, would be an appropriate derivative. Question that up? I want to look at your problems and see what. When you get into asymptotes, it's really hard to draw them. Those are always multiple choice. So that certainly helps. All right, let's say that's your f of x. I'll let you guys try. Is the origin an important point on your derivative? It's not. And a lot of people make the mistake and think just because the origin feels like it's supposed to be important, but it doesn't matter really. Good, you guys are good. Okay, so I know the derivative is 0 right there because the slope is 0. So I go up there. I noticed you guys aren't even writing the stuff, which is totally fine. I think that means you're understanding it well. But if I start off with like that'd be that many wiggles. I have to flip that over. This Phoebe's not sure. That, and then it'd be like 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 that. Or it could be the opposite, right? I can't draw that one because. So I'm looking for a line, a diagonal line, and I know that my original graph is decreasing here. So what has to be true about my derivative? It's got to be negative or below the axis, and then I've got to be above the axis, and I've got to have a diagonal line, so it's going to look like that. Or it's going to look like that, or it's going to look like that. Like those are all fine. No one can like know what that is, but it's got to be an upward sloping line. All right. We're going to go another one. What's the derivative? So I know I can do extra colors here. But try to sketch the derivative of that, or just think about it. Like go to right. Sure. Dotted lines and one So let's say this was like y equals 5x. What's the derivative of y equals 5x? 5. So that would be a horizontal line of 5, right? What if that was y equals 2x? What's the derivative of 2x? 2. So it'd be a horizontal line of 2. And that's like another wiggle down of the horizontal line, right? I don't know what the slope is, so I don't know the actual number, but I am comfortable just drawing a horizontal line above the axis because I do know that slope is positive. With me? Did I get a question or is it? Okay. Draw the derivative of that. It doesn't matter where you put your horizontal. You could have put a 2, a 5, a 10, whatever. Those are all just numbers. What's the derivative of a number? 0. So what's the slope of that line everywhere? 0. So it'll just be the axis. And then what's the derivative of that? What's the derivative of 0? 0. So the derivative of that is just that, over and over and over. And that only works if it's polynomials. Like if you're at a sine or cosine, the derivatives just like wiggle back and forth, and it doesn't have that like progression of losing wiggles. But if you have a polynomial, it does. Questions on that scenario? Let's look at one with an asymptote. These are a little tougher. Not sure I can draw them great, but let's say something like this. Now your choices. You'll have to write the choices if you don't want to. I should do it before I start just writing. So see if you can pick out which one of those it is. Or maybe I screwed up and it's none of these. So if you just look at the increasing decreasing bit, it kind of sorts it out for you. But this original graph in this part is increasing or decreasing? Increasing. My derivative needs to be above the axis. And isn't it increasing faster the whole time? So that's why this is gone now. So this has got to be since my original graph is increasing, my derivative needs to be above the axis. And because the slope's getting bigger, my derivative should be getting further above the axis. What about this section? What's true about it? Is it increasing or decreasing? It's decreasing, so my derivative graph should be below the axis because the derivatives are all negative. And aren't the slopes getting closer to 0? So that's why you see these slopes like getting closer to 0. How's that? So go to 5-8, and all I'm worried about is do the matching part. Work together. Don't check your answers until you're done. See what you can do. Yeah. Don't check as you're